so welcome to the Category 2 workshop. As we said in our Discord announcement, this is going to be a physics-oriented category. So for those of you who haven't taken physics, this is just know this is going to be a really heavy category, so please make sure you pay special attention to today. If you reference it in the future, we're going to have a recording of it on YouTube, and just know that, again, this is really heavy, so if you want to do a physics event in the future and you haven't taken physics yet, make sure you do have, we'll make sure you have a physics, someone who's taken physics as your partner. Because there are some portions of these events that you can do without physics. Maddie and I have for the past few years, but just remember, there's a lot to know. So make sure you have the drive to study yourself. Maddie, do you have anything you'd like to add?
I would say I think all these events should be done by not sophomores, juniors and seniors, but mainly seniors. But if you're a sophomore, I did Sons of Music as a sophomore, but I had to study independently by myself. So it's a lot of studying. So make sure you want to contribute that much, otherwise don't do it. Okay, that's all.
But it's not impossible because we do need some people to do these physics events if we want to get into nationals. So we do need that drive. We do need that self-studying will if we're not going to get enough seniors on our team. So just keep that in mind as we move forward. Okay, so we're going to start off with detector building. Okay, so what is detector building? So detector building is a study and a build event. It has two portions, so we're going to go ahead and start with the build portion. So for detector building, you have to build a temperature sensing device. And there are a lot of YouTube videos online where they go through step-by-step how to make the device. It's actually not as complicated as it seems. You use an Arduino or a Raspberry Pi, you program it, attach some wires so that it connects to your computer or calculator to display the program. You know, it's not too difficult when it comes to the building. And you also need to include a design log with your build. The design log will cover things like a picture of your build or the materials you included and why you included them. Or you need to have a graph on your design log of the data you collected before the tournament, stuff like that. So for tryouts, please make sure you know what you need to include in the design log because this is really testable. This material is really testable. And then at the tournament, you have to test your device. And you're given 4 stations to go to at the tournament, and at these 4 stations you have to test the temperature of the water, and depending on how accurate you are scored. So remember, 4 stations. Okay, so now let's go to the written test. So for the written test, you have 50 minutes to complete it. Actually, no, not 50 minutes. For detector building, you have the whole time to complete the written test as soon as you finish the build portion. Device testing. So the written test will usually cover the basics of your device components. It's going to have some physics in there, some equations. I would say most of it is from Physics 1. And then know what you can bring to the event. You can bring a laptop or a calculator to display the program in your device. Last year or this year we used a laptop because the calculator, it was too expensive for us to do that. You can bring a 2-inch or smaller 3-ring binder. So this is really important. It's a binder event, so you need to know how to make a binder. And if you attended our workshop yesterday, you'll know how to when we discussed ornithology, because ornithology needs a really good binder. It's the same with detector building. And then you need 2 calculators of any type. And please make sure you bring 2 calculators because at Rice, Jimmy and I forgot to bring a calculator. Like I had a calculator, but it wasn't a TI-inspired calculator. We recommend TI-inspired calculators. And the thing is, we got one question wrong because we weren't able to find the regression of it without a calculator. And I think that cost us our rank. We weren't able to place. We got like 5th. So and it was like 10-point questions. So make sure that you bring 2 calculators, and it is recommended for a TI-inspired calculator to be used on this event. Okay, so what do you need to know? So I've highlighted the general topics that you need to know for detector building, and then the second bullet explain the specifics that you need to know for tryouts. So starting with how to build a temperature sensing device. So because you can't draw detector, like the device, you can't draw it, right? So we're going to ask you just the general steps to tell us just generally how you can build this device. We don't need the details, but we do need you to have a general idea. So on the resource packet, we have included a video, actually I think 2 videos, that include some steps. They're only 5 minutes long, so it shouldn't take too long. Just watch through them and you'll be good for this portion. The process of calibration, working with raw data and determining real-world relationships. So for this portion of the test, you basically need to know how to make or find the equation of some data that you get on the test. This is both for tryouts and for detector building in general. You're going to be given some data on a table, and then you need to find the regression, the linear equation, the logarithm equation. So a TI Inspire is recommended for this, and if you don't have a TI Inspire at home for the tryouts test, we'll probably adjust the question for you. And then you need another theory of LEDs, working principles, and applications. This is really important because every detector building test will include some questions regarding LEDs, and it's very testable and it always appears. And same goes for tryouts. We are going to ask you about LEDs. So if you looked at the resource packet, I have provided you a Wikipedia link about LEDs. And believe it or not, every practice test I've seen about detector building has the answers on that wiki page. Every single one. I looked at it myself. So if you want to do detector building, you need to memorize that Wikipedia page about LEDs because it's always tested. But for tryouts, we're not expecting you to read through that whole page because it's really long. So we provided, I think, 4 or 5 pages of reading for you to read about for LEDs and be prepared to be tested on them. For example, some parts of the reading, I believe I included like the advantages of LED. So make sure you can list the advantages and explain them, stuff like that. So we need you to pay attention when you're reading about LEDs. Then you need to know, now let's get into the physics part. So now you need to know the operational knowledge of basic device components. So there are a lot of device components, a lot. So we've broken it down. You just need to know inductors and electromagnets, meaning you need to know what they are, how they're used, you know, what's their application, and maybe the basic math behind them as well. Again, this is physics, this is physics oriented, but you can still do some research on your own and be able to answer like level 1 or 2 questions about them. On the packet, I have not provided you with resources to study them. We want you to go and do that yourself so we can test you on how well you can research on your own and answer questions. So for inductors and electromagnets, just search them up. Usually Sayuli Wiki or Sayuli Inc. is a really good resource you can use for anything Sayuli related. And then finally, you need to know relationships between resistance, voltage, and temperature. So by relationships, we basically need equations. You're going to need to know a lot of equations, and there are a ton. And again, you learn this in physics. And because I know a lot of you guys who have signed up for Category 2 have not taken physics yet, we're not going to ask you to read through a physics textbook in 4 weeks. Instead, we just need you to know about Ohm's law, and we need you to be able to apply it to a problem. So know what it is, the equation, and be able to solve some problems. Again, since you guys have not taken physics, most of you guys have not, please, 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 please understand what I'm about to say. So on the tryouts test, we're going to have 3 level questions for you, okay? Level 1 questions are going to be basic, meaning you don't really need to know any physics for them, and they still appear on the test, but they're really basic. So level 1 questions would be like how you would build a temperature sensing device and the process of calibration, because we did that in algebra 2. Level 2 questions will be more applying, meaning you have to research physics, but you don't really need to take the class necessarily, like you can do it on your own. So questions about LEDs especially would be in level 2 questions. Level 3 would be the actual physics that you've got to know, and you need to have taken physics to be able to ace, unless you want to self-study it yourself. That would include Ohm's law and maybe some parts of the device components. So if you want to do detector building, which you can, just make sure that you can ace level 1 and 2 questions, and then try a level 3 questions so you can see your potential in physics. Again, it's not impossible to self-study physics. I remember Madia last year self-studied physics 1, and she would tell me about it at school. So it's not impossible, but just make sure you're ready for it, because we do need some strong people in physics. We don't have that many right now, so we want you guys to be able to be strong in it. So the next slide. Okay. So here I've included the design log that Jimmy and I created this year for detector building. So as you can see, here's a picture of our device, just so you guys can see what to expect. It's really not that complicated. You just connect the wires accordingly, program it, and there are also sample programs online. There are so many tutorials. The build portion should be good. The components. So for the components, we had to explain, the different parts of our device and their function. So we did that on the bottom. The next slide is a continuation of the design log. You can see on the top left, we were still listing off the parts of our device and explaining them. Bottom left, we explain the construction and how we waterproofed it, because you have to waterproof your device since you're testing water, right? You want to make sure your device doesn't like blow up or something. Okay. And then on the right, on the top right, we have our data table of some data we collected before the tournament with our device, and then a graph that displayed this data. And then finally, on the bottom right, we included a snippet of our program that we used to make the device possible. So this is what you would need on our design log. I just wanted to show you guys so you have an idea of what the build portion looks like. Okay, so I'm now going to go through the different topics of detector building and give you guys sample questions so you know what to expect of tryouts as well as in general for detector building. So starting with process of calibration, like I said before, this is really straightforward types of questions. As you can see in this problem, sorry for the glare, but here's a data table. It looks like a lot of numbers at first, but when you read the problem, it's actually asking you for the relationship between P and apparent magnitude in V. So you actually only need to know the numbers between, under P and V. And you would have to use a calculator to plug in the data and then find the linear equation and logarithmic equation. So again, just use the regression portion of your TI Inspire, and you should be able to get full points on this question. Theory of LEDs, working principles, application. So this question right here I have for number 2. This is very likely to appear on a trials test, something like this. So as you can see, it's labeled LEDs, and A is asking, are the colors monochromatic by nature? For here, the answer would be no. LEDs are not monochromatic by nature. You would have to know that through the articles we include in the research packet. And then B, list the advantages and disadvantages of LEDs to incandescent light bulbs. So then you would need to list some advantages and disadvantages. And this is from a practice test before. This is actually at one of the solidity tests. And expect the same thing on tryouts. Really, it's not, again, see, you don't really need to know, you don't really need to take physics to answer this, but you do need to study, if that makes sense. So this would be a level 2-ish question, or 1. Okay, operational knowledge of basic device components. This is where physics come in. And for 4A, you have to explain the theory behind a transformer. So this is an example of one device component, and you would need to explain the theory behind it, meaning like how it works. Transformer isn't one of the things you need to study. Again, you need to know inductors and electromagnets. So maybe you should expect a question like explain the theory behind an electromagnet. So stuff like that. This will be a level 2-ish 3 question. Okay, now this is a level 3 question. So relationships between resistance, voltage, and temperature. So here you would need to be able to use your physics knowledge about how to write this situation into an equation. So here it's asking you to write equations for the rate of heat exchange in terms of radius, resistivity, length of the wire, thermal conductivity, inductor voltage, difference temperature. So that's where the physics come in. This is what I mean by you need to be able to have at least a partner who's taken physics to answer these kinds of questions. So since we're not going to ask you something as absurd as this, we're going to ask you stuff about Ohm's law instead. Next slide, Claudia. Okay, so that's all I have to say with detector building. And to earn points today, you're going to need to answer this question. Just text Tracy privately in the chat. What are the 2 basic device components that I need to know for trials? And then Nadia, let me know when you have the answers. And then if you guys have any questions, please let me know. And if you have any questions in general, please let us know, because again, if you don't understand what we're talking about today, you're gonna have a hard time with tryouts. So just make sure we can clear up anything you'd like.
Tracy, do you have all the answers?
I have all except for one. I guess
Um,
we could move
Oh
on.
yeah, sorry, come on, Tracy. Okay, I thought you were sending it to Maya. Sorry, Tracy.
all right, I think we can go to the next slide, Tony.
Alright.
Okay, so Circuit Lab. So Circuit Lab tests your knowledge on electricity and magnetism. So you'll see the details in the other two circles. So before that, you are allowed to have a 3-ring binder of any size, and you're allowed to bring 2 calculators of any type. So I think the graduates who did the event before, they can go further into it. And then you'll have a lab portion and a written test portion. In the lab section, you're given a circuit and you need to use the voltmeter and the wires, batteries, resistor, etc. to figure out whatever they're gonna ask you something, and you're gonna use the measurements given to you to figure out the one that's asked about, if that makes sense. So here I wrote, find the value of a resistor in a circuit using voltage measurement. Then power, you need to know how power is supplied to a circuit. Then construct electromagnet using wire and battery. And I think I wrote board, it was supposed to be bolt. And then use wires, battery, and resistors, and also LED lights to light up two lights which are equally bright. So you need to know how to practically create a circuit and work with it. For the written test portion, you need to know basically most of the things you learn in physics too about circuits and magnets. So you need to know the history made by different I don't know how you say it. Okay, anyways, different scientists like Ampere, Coulomb, Volta, Ohm, Tesla. Then you also need to know the hazards of static electricity. Then you need to know Coulomb's law. Then you also need to know DC and AC current and the differences between them, their characteristics, hazards, all of it. You also need to know characteristics of LED. So it's also like, this is where the detector building and circuit lab combine, or like they have this in common, like knowing about LED. Then you also need to know the concept of voltage, current, resistance, power, energy, and Ohm's law, just like detector building. And then you need to know about magnets, like magnetic poles, electromagnets, generators, transformers. Again, some similarities with detector building. You need to know about the current laws and also characteristics of p-n junctions. I think Rahul and Siddhan can add more onto it because they are very experienced with it. So Siddhan, would you want to add something?
So for the lab, one of the labs was using a breadboard, like detector building, where we had to light up the LED. And another one of them is like finding the resistor value using the colors. So the only thing I would recommend is dividing the work like evenly. So like I did DC or direct current while Rahul did AC. So just dividing the work and making sure your binders organized would be a good start.
Rahul, do you have anything?
Yeah, I would kind of agree with that. Is that I would say it's kind of split between stuff you learn in like AP Physics 1 and 2 and then like more advanced stuff. So if you want any chance of like placing or doing well, first of all, you have to do the labs right. But I mean, most people there are going to get the basic stuff like Ohm's law. But what really sets you apart is that if you go out of your way to research some of those more advanced topics, if you do that, you can do really well. So yeah, so this is involved like some research, but it's really helpful.
Okay, thanks, Rahul and Siddhan. Tony, next slide, please. So for the tryouts, you will have to know Newton's second law. That's going to be a first level question out of the 3. You need to know historical perspectives of electricity made by only 2 scientists, in the actual test, there are more than two. So we're just gonna test you on the two mentioned here. You need to know about direct current, its hazards and advantages and everything. Everything is mentioned in the packet, so just look to the research packet. Then know about the circuit components like battery, resistors, wires, etc. Then you also need to know DC circuit types, so simple, closed, open, short, the differences between them and what does each of these mean. So make sure you know that, and then know concepts and concepts and units of current, voltage, resistance, and using Ohm's law. And these are most likely going to be a level 2 question. And when we're also going to ask you about Ohm's law calculations, which is voltage equals current times resistance. So that's most likely going to be a level 3 question. And then you need to know the symbols of components of a circuit. So you know how to, so that if you know the components, you'll be able to draw a circuit on the paper. So as I said, the next one, be able to draw a circuit using symbols, be familiar, yeah. And you'll have to answer questions about flow of current, flow of electrons, whether lights will be equally bright, etc. So you need to know the difference between parallel circuit and complex circuit. Then you need to know from which direction the current flows and from which direction the electrons flow from. And make sure you can do calculations by looking at the diagram of a circuit. You'll see an example in the next slide. So I would say just go through this, just look back at this presentation after the meeting if you're not sure about what to study, and reach out to any of us. And yes, read through the packet. That's the most important thing you should do. Tony, next slide, please. So here are some examples. So if you see number 3, you'll be able to fill. So they're going to ask you whether 0.9 ampere of DC current be able to be felt by human body and if there are consequences. So yes, the answer is yes. You're going to feel it and you'll most probably even die. So yeah, so know the characteristics and hazards as I mentioned. Then number 8, this is what I meant by saying you need to be able to do calculations based on a diagram that's given to you. So that's an example. They're asking you to find the power that would flow to the circuit. Then there's the multiple choice questions, 27, 28, 29, and then 26. So you'll have both multiple choice and free response as well as a lab to the test. Next slide, please. Before I go on, Rahul, Sivan, did you think I missed anything or I covered everything else? Like, is there anything you would want to add again?
No, I think you covered everything.
Yeah, you did pretty good.
Okay then. So, quick check. What type of binder are you allowed to use for this event? In order to get points for today's meeting, please text your answer privately to Tracy.
And again, if you have any questions, let us know. This is the time to ask.
Yes.
And also, Detector Building and Circuit Lab, if you notice, they are pretty similar. Detector Building was released though recently. So a lot of people use Circuit Lab resources to study for Detector Building. It's just Detector Building is more specific. So Circuit Lab includes a lot of stuff, but Detector Building will be like, we have a whole section related to LEDs. So that's where it differs.
Okay, we can move on now.
Okay.
Okay, cool.
So sounds of music. So sounds of music, it's a test. You have a test portion to it and also a build portion to it. So for the build part, you need to build an instrument and be able to play a scale on it. And for the written test, you're going to be tested on your knowledge about sounds and music, physics of sound and music theory. So to go into the even details for the build part, you need to build an instrument and you need to be able to play a scale starting from F of second octave. So you need to play 8 notes. And in the middle, after the 4th note, you need to make an octave jump. So let's say you start from the 2nd octave of F. After you play the 4 notes, you need to make an octave jump and go to 3rd octave. Then you need to be able to play Twinkle Twinkle Little Stars, and that's within 15 seconds. And if you know your instrument well, if you know how to play Twinkle Twinkle Little Stars, this should be an easy point for you. And you can also earn bonus points here. So you know how you're gonna play an octave, your scale, right? If you can play a note that is not in your scale, you'll be able to earn a bonus point. So it can be a note below F of second octave, or it can be above whatever your last note of whatever your last note is from your scale you will play. So the build part is kind of like the exam part is easy, but the time you need to put into it is a lot. So we spent about 3 to 4 months on the instrument we made. We will see a picture later on in the slide. So that's the build portion. For the written test, you get 20 minutes to answer questions, and you're tested up on general principles of acoustics, so wave theory, how it affects, Bernoulli effect, etc. Then you need to know terms related to sound and sound production, so intensity, Doppler effect, which is like when something is moving away from you, how the person receives the sound. Then you need to know about longitudinal waves, etc. And then again, now this is when we also come to the musical portion. So you need to know about harmonics, overtone, what is a fundamental frequency. And then you need to know about the design, function, and construction of the instrument. So you need to know about how to make and how your instrument makes the sound. And as well as you also need to know how other instruments of like percussion and then flute, open tube, closed tube, you need to know about all of those. So you need to know the varieties of instruments. That's why you also, I did not mention it here, but you are allowed to have a binder. And I would say in your binder, put all the details you can find about the instruments. Then the last part is about music theory. You need to know notes, scales, intervals, time signature, and the tempos, and other music theory related terms. You'll find more details in the Siley Wiki, like their descriptions and all. So yeah, that's the test question. Tony. So for the test, for the tryouts, you need to know the difference in longitudinal and transverse waves. So they're different. You need to know the difference. You'll find it in the research packet. Then you need to know the physical quantities of sound, so pressure, power, intensity, amplitude, and speed. You'll also see a speed formula there, so make sure you know how to apply it because you're going to get questions. You're going to get math level 3 questions. You need to know music productions, fundamental frequency, partials, overtones, and harmonics. Then again, sound phenomena, superposition, diffraction, reflection, resonance, Doppler effect. And you only need to know how to calculate the Doppler effect only for these tryouts. And then no music theory like note names, sharp, flat, natural, key signatures, tempo, etc. So if you're in orchestra or in band, you should be fine with the music theory portion because you have been doing it for years now, like 2, 3 years, 4 years. So that should be pretty simple for you. And the last part, you're gonna get a situation-based question, which is gonna be regarding your instruments. So for example, your peg broke like 10 minutes before the competition. What are you gonna do? Are you gonna not go to the event? Do I come up with something? Yes, so it's for you to be able to we're gonna just test whether you can make quick decisions and improvise last minute. You will need that skill a lot. Okay, next slide, please. So here are some possible questions. You'll see the first one, which material of the following would be the best absorber of sound? So the answer would be wool. Then compression and rarefaction occurring. You should know this if you read through the packet. The answer is B. Then what is the fundamental frequency of an open pipe with length 1.5 meters? So 19 and the other one, the one below 19, they're both math questions. So you'll find 2 or 3 formulas in the packet, know what they all mean, what they all stand for, and just apply it just like the way you're seeing it here. So the math questions are going to be similar to this. Okay, Tony, next slide, please. And this is the instrument we built last year. So this took us like around 3 years. I mean, not years, what am I saying? 3 months. So on the left side, it's like our completed instrument, but we didn't attachment peg, I think. Yeah. So then you'll see the other one like here and the other one here. So yes, here are just some pictures. And for an okay, I'll give you a situation like this is what we faced. So last year when we were doing the event, we were at the Rise Invitationals, and one of the pegs, it broke, it fell apart. So if you can see the peg, there's a handle and there's a stick. So it fell apart. So like we were twisting and trying to tune it, and it just broke. So we had to like come up with a quick decision there. So we used a pencil and we somehow made it work. So you just need to be able to make quick decisions and know how to improvise. And for this reason, you need to know well about your instrument so you can make changes even if it's before 10 or 5 minutes the competition starts. So yeah, just make quick decisions. Next slide, please. Okay, so now a quick check. After what number note do you have to make an octave jump when playing the scale? Text your answer privately to Tracy to earn points for today's workshop.
Also, quick note, you don't have to make a viola like Maria said. I know we didn't discuss that. You don't have to, but
Yes,
you can.
you can if you want to.
So when we were freshmen, the president, Joshua, he told us to make a flute. I think it was a flute or clarinet. It was a flute. Oh, no, a recorder.
Recorder.
So that's usually the easiest instrument you can make for sounds and music. That one probably wouldn't take 3 months. But Maria just wanted to, go the extra step and make a viola, which is I thought was really cool. But it's really up to you. You can make whatever.
Any instrument, but just be able to play a scale, make an octave jump, play, and be able to play Twinkle Twinkle Little Stars. And also, I would say like for circuit and detector building too, you need to study. You need to know a lot about physics, do research and everything. But Sounds of Music is, I think, an easier event. So you just need to study really hard and be able to use the math because it is just testing you on the wave portion and just music portion of, or the sound portion of physics. So I would say this is not too bad, but still it requires lots and lots of studying. So I would still say like have a partner who's a senior and a junior, like a team of a senior and a junior, or a senior and a sophomore. So just have someone who has who still has some experience with physics,
Right.
Okay, we're good to move on.
Awesome. Okay, astronomy. So before I begin astronomy, I just would like to say this event is notorious for being one of the most difficult and annoying events in all of Science Olympiad. So as I talk, please pay special attention. And Rahul, he's taken astronomy. He did really well in it at regionals. He's going to add on after I talk. So please ask questions to him. He's an awesome source of answers if you need them. Yeah, just please pay special attention to what I have to say, because if you don't, you're gonna probably get a 0 on the tryouts test. I'm not kidding. Okay, so please pay attention. Okay, next slide. All right. So what is astronomy? Okay, so usually when you think of astronomy, you think Science Olympiad is gonna ask you about questions about planets and sun, right? Kind of like in 8th grade when we went over, basic astronomy, but Science Olympiad, of course, doesn't want to just test you on that, right? So astronomy is one of the most physics-heavy events. It's very heavy on physics. Basically, it covers star and galaxy formation and evolution. And by the way, it is just a study event, so it's just a written test, and you have 50 minutes to take it. Now let's go over what you can bring. So you have a couple of options when it comes to astronomy. So you can either bring 2 binders, or you can bring 1 laptop and 1 binder, or you can bring 2 laptops, okay? So just in case that's confusing, let me say that one more time. So 2 binders, 1 laptop, 1 binder, or 2 laptops. And if you use a laptop, you need to be able to access the information when you're offline. So you need to have everything on a Google Doc or PDF. Not even a Google Doc, sorry, a Word doc or a PDF, because you have to access it offline. So that's up to you, but those binders are really needed. And for astronomy, please make sure you know how to make a binder or how to put information on your laptop. It's really important. Okay, next slide. Okay, so this is not what you're going to need to know for tryouts, but I did want to include the information you're going to need to know for astronomy if you want to do astronomy this year. So this looks like a lot at first, but I'm just going to break it down real quick. So on the top, it says you need to use information with the following stuff. So meaning you have to be able to use an H diagram, or you need to be able to use stellar magnetism classification, or you need to be able to use GS9 imaging and analysis software to be able to answer questions. So that means you need to know how to read an HR diagram. You need to know how to read these imaging analysis softwares, okay? Now, A, B, and C tell you what the questions are going to ask. So you have to use the stuff to answer these questions. So A says you're going to be asked questions about stellar and galactic evolution, including the following. So chemical composition, for example, or color index, or galactic structure and interactions, dark matter and energy. Okay, so you have to answer questions about these things. B says you have to use Kepler's laws. You need to be able to know Kepler's laws and apply it, or Hubble's laws, redshift, Hubble's constant. Okay, that's where the astrophysics come in, because you need to be able to know Kepler's law and all these formulas and physics to answer questions about space objects. And then C tells you the specific space objects that are going to be tested. So all these random numbers and letters, believe it or not, are names of space objects out there. So these are the space objects you would need to know, and then you would need to use HR diagrams and stuff to answer questions about those space objects, which are about A and B. Okay, I know that's complicated at first, but on the next slide, I'm going to break down what you need to know for tryouts, because that's a lot of information. Just looking at that, I'm probably like, what? So here's what you need to know for tryouts, okay? Okay, so obviously you need to know the general structure of the event. That means just go through the rule book and read through like what you can bring and stuff, because we might ask one question about it. Not too much though, so don't spend so much time on that. Stuff below is important. So first you need to know F equals MA. So before we created the research packets, we called Raul, we asked him, hey, what do we tell people to know for this? So, and he said that F equals MA is like the basic foundation of all physics. You need to be able to know this equation to do anything physics related. So especially for astronomy, we're going to ask you F equals MA. Of course, they might not directly test that, but we want you to know it. So you can just search up some videos, practice questions, be able to use it, know it. F equals MA. That would be a level 1 question, by the way. Okay, so on the previous slide, you saw all those space objects, right? So we're not going to ask you to go through all those space objects. Instead, we've listed 1, 2, 3, 4 that you're going to need to know. 3 quasars are tiny as 1. So NGC 2623, those 3 quasars, M87, GW151226. You need to know these space objects. And at first, you're probably like, okay, what do I need to know? And yeah, there's a lot to know, right? So on the resource packet, we've actually identified what exactly you need to know for each space object. Again, we're trying to help you out. So for NGC 2623, I might have wrote on the resource packet, you need to know its structure and its evolution, or maybe you need to know its light spectrum or whatever. So, and then we give you articles so you can go through them and find the information, or we might have even told you to go do your research on your own. Okay, and then with those objects, you need to be able to use those 2 things, stellar magnitude and classification and multi-wavelength images, to be able to answer questions about those objects. So remember on the previous slide, there were a bunch of stuff you need to be able to use. We only made it 2. So in stellar magnitude and classification, you'll see on the resource packet, we've included like how to read an HR diagram, or how to read the spectra class, stuff like that. You're able to read them so you can answer questions. And for all those space objects I've listed right here, these 4 space objects, you need to make sure you know their multi-wavelength images. Memorize them, because we're not going to let you have a binder with you when taking the test. We're just going to ask you to memorize them just this time. So memorize their multi-wavelength images so that you can match the images with them, because we're probably going to ask you that. We're probably going to ask you to match the object with the image and then answer questions. Kind of like, oh, hey, the image in A is what? So then you would have to say NGC 263. And then you'd be like, okay, so what is this object's evolution history? Okay, then you would have to write that. So be able to use those two. Okay, and then you have to use those two to answer questions about stellar and galactic evolution, luminosity, color index, supermassive black holes, galactic structure interactions, and stellar mass of each of those space objects. And again, I specified it in the resource packet, so you're not like all over the place. It's really easy to get all over the place for astronomy. So we've broken that so that we just want to see how, you know, how much potential you have for astronomy. We're not asking you to go get lost. So we don't want you to get lost here. So I hope that makes sense. Okay, and then finally, you have to understand Hubble's law and be able to use Kepler's law, 3 laws, to find out orbital motions of galaxies. So we're not asking you to apply Hubble's law, we just want you to know what it is. But for Kepler's 3 laws, there are 3 of them, 3 different ones. You need to be able to know them and apply them to some problems to find out the orbital motions of galaxies. So that would be level 3 question. This will help us distinguish those who know physics and who don't. And don't worry, if you don't know physics, that's fine. You just want to know where you are so we can partner you up with the right person. Because again, remember, we want to make nationals, okay? We are very adamant on this. So we need to make sure for every event we can be successful. So if you want to do astronomy, make sure you have level 1 and 2 questions down. Level 3 will be for physics. Maybe try to attempt them. And if you have taken physics, please help us out and try to ace these events so that we can have some more physics oriented people for these physics events, right? So right now, if you have questions about how the trial test is going to be structured, please ask, and please make sure you know this slide right here, because that's what trials is going to look like exactly. We're going to have this on the website if you want to refer to it later. It's also in the resource packet, but I'm here if you need any questions answered, because this is very complicated at first. Okay. Let's move on to the next slide. If you have it, just text in the chat and I'll answer them at the end. Okay, so now I have some types of questions you might see in astronomy. The first one is a free response question / picture matching. So this is usually at the beginning of the astronomy tests. They'll have they'll have some images of space objects, and then they'll ask you to identify what object's in there, and then they'll ask you questions about it. So you can see on number 1, it's asking which object is characterized by its twisted cosmic knot. So you would need to know, first of all, which object is that. Remember the list of objects on the side of the website on the rulebook? So you would need to know which one of those is characterized by that, and then identify that object with its picture, which is right here, A through F, and then answer questions about it. So if you just look through that, that's kind of how the first part of astronomy goes. And for trials, expect something like this. And again, we've broken it down on our resource packet, so you don't feel overwhelmed. Next slide. Okay, so astronomy multiple choice questions. So these multiple choice questions are going to ask you about, basic stuff you need to know about astronomy. For example, like what is false about elliptical galaxies? So when you're studying astronomy, you would probably come across elliptical galaxies, and here you would need to apply your knowledge about it to answer this question. So here it's not necessarily physics. Here you just got to know and study really hard astronomy. So expect stuff like this on the test. And again, the topics that we're testing you on for the multiple choice is on the resource packet. But the next slide is where it gets beautiful. So astrophysics. So that's the hard part. So here are 3 examples of some problems that have been asked on a previous astronomy test that needs physics, basically. So as you can see, for example, on I probably included it, but I didn't. But, oh yeah, I did. Okay, so number 3, the first question. See, it's asking you to apply Kepler's 3rd law to the situation. So that's something we might ask you on tryout, so we can see whether you know physics or not. Okay, so for astrophysics, you need to be able to know these formulas, equations that you learn in physics 1 and 2 to be able to answer these questions. Like, what is the apparent magnitude of a star that's 4,000 light years from Earth and has an absolute magnitude of 6? So you need to know how to solve that based on light years and absolute magnitude. Same goes with number 2. You have to draw a diagram of the sun orbiting the center. And at first you think that's easy, but then it says include velocity, acceleration, and force. that's where physics comes in. So this is kind of a general idea of what astronomy is, but Rahul knows a lot more about astronomy than me. So Rahul, would you like to add on?
Okay. So in my opinion, I've only done like 5 events in Science Olympiad, but in my opinion, I think astronomy is the hardest. But the good thing about that is that if it's the hardest, then it's hard for other people too. So you don't have to be, I think like what's kind of overstated. I'm not like an astronomy expert. I'm not majoring in astrophysics or anything. So I feel that to do well in astronomy, you have to know more than the other people, if that makes sense. So, um, so for example, um, so when I did it, um, I was a senior last year, and I also had a sophomore doing it. And for she did all the image matching stuff, and I did the more physics oriented upper stuff. So what I would recommend for this is that first of all, you like the math is harder than any of the other events. The math is pretty hard, and the physics is pretty hard as well. But that doesn't mean it's like not doable. So it's just really about getting some of those key concepts down. Like you have to understand some of the very fundamental stuff, and then if you understand the fundamentals, then after that you can do really well. Because a lot of people in this event, I feel, go straight into the high end stuff and never care about fundamentals. And so that's why I told them to put F equals MA and stuff like that. So what I would recommend is that if you're a freshman or a sophomore, definitely try to sign up for this. And be that person that matches images, that knows some of the basic concepts to help do the MC. And if you're a junior or senior, please like sign up for this event too, so you can do the higher end stuff. And I think all this is just learning how to do the concepts. Also, a lot of it is like reading just like what's going on in physics today. Like, oh yeah, there's like you have to know like the one I took, there are lots of different particles and stuff like that. They didn't know like crazy undergrad physics, but the good thing is that nobody's an undergrad taking this test. It's all high schoolers. So as long as you work hard and just know a bit more of the college stuff than the other people, you'll be able to do fine. So yeah, that's my advice.
Thanks, Rahul. Yeah, so let's pull astronomy. It is a difficult event, right? So that means everyone's going to find it difficult. Easy tests are also not a good sign, right? Because then you would need a perfect score to get, rank 1. So also I don't want to put it out there like it's impossible to do this. We do need some people doing these events. So if you can study physics and if you listen to Rahul's advice about it, I think we're going to do fine. And of course, we'll help you out. We've got a lot of resources to guide you there. So if this is something that interests you, go for it. Next slide. Okay, so this is a true or false question for astronomy. The question is, you can bring up to 3 binders for astronomy. Is that true or false? Just text Tracy privately, true or false. Give you a minute. And if you have any questions, again, please let us know, because that was, I think, a bit heavy. So please ask.
If you have any questions while studying for this event, just reach out to us through Discord or Remind. We'll try our best to answer your questions.
Right, and like don't be afraid to ask, because questions are always good. It helps us learn too. And if we can't answer them, we can always ask. We can always text one of the graduates to help us, so we can have the answers ready for you. Just make sure you study.
Okay, I think we can move on.
Okay. All right, thanks, guys. Again, thank you so much for your interest in this category. It is very needed. We really need some help here. And again, we are so thankful for you wanting to go that extra level. We really need that. If you have any questions, let us know right now. We will answer them. If you don't have any questions now, you can text us in Discord anytime. And like Maria said, if while you're studying, you come across something difficult, we're here. We'll answer them. Yeah.
Anything?
And for tryouts, if you can ace level 1 and 2 and try level 3, that's a really good sign. Just want to put that out there. Okay, I think no questions. Maudie, do you want to add anything before we end?
No, I think we covered most of it. You covered most of it. So I think we can end the meeting here.
Okay, guys, thanks for coming, and we're really looking forward to seeing you soon. Bye.